Hello everyone, we're going to continue our lesson on section 19b about the area between two curves, and we're going to continue going through this introductory slideshow. I noted in the YouTube link that this is not my own slideshow. You can get it at this link right here, slideplayer.com/slide 5716141. So if we want to find the area of the region bounded from above by y equals x plus 6 and below by y equals x squared, and bounded on the sides by the y-axis, or where the line x equals 0, and the line where x equals 2, that means we're finding this kind of weird shape right here. We're going to do that by following our formula from the previous video. So we're going to take the integral between when x equals 0 and x equals 2 of the top function, x plus 6, minus the bottom function, x squared dx. Well, the integral of x plus 6 is x squared over 2. The integral of 6 is 6x. And the integral of x squared is x cubed over 3. So that's my integral. I need to evaluate it when x equals 2 and when x equals 0. So here, if I plug in 2, I get 4 over 2 plus 12 minus 8 over 3. Simplifying, you get 34 over 3. And if I plug in 0, all of these terms will be 0. So I end up with an area of 34 over 3. Here's another case where we are finding the area between the function x plus 6 and the function x squared. And it's between, it says the region that is enclosed between these curves. So they didn't tell us the x values. They didn't tell us the boundaries that we need. So we have to figure out, where do these points cross? If we have a picture, then it's easy to see. So I could draw this picture out if I wasn't given it. Or I could set the equations equal to each other, x squared equals x plus 6, and find those points of intersection. Okay, I need those because if I want to find the area, then I need to say the area is the integral between when x equals -2 and when x equals 3 of the top function, x plus 6, take away the bottom function, x squared dx. Okay. And as we saw in the previous example, the integral is x squared over 2 plus 6x minus x cubed over 3. We're evaluating that between when x equals 3 and when x equals -2. So I plug in 3 for x first, and then I plug in -2 for x second, and I subtract those two values. In this case, they're going to add together and give me 125 over 6. Okay. Now, in the case when both f and g are non-negative, okay, that means when they're both above the x-axis, then the area between the curves can be obtained by subtracting the area under y from the area under x. So all they're saying here is the area under f of x is this big blue area here. The area under g of x is this blue area here. So if I want the area in between those two, I can take the big blue area and subtract the small blue area. It's like a visual description of our formula.